Let's talk about inequalities and compound inequalities. And we're going to start by looking at these symbols and doing a review of what they each mean. And so this symbol up here in the top left means less than, not including. This one right here means less than or equal to. So anytime you see that line underneath, you've got the equal to part comes along with it. And then we've got greater than. And then we have greater than or equal to. Now it's important to note that these all have these meanings if you're reading from left to right. So for example, if we write the inequality 4 is less than 5, this symbol right here is the less than symbol. And that works if you're reading from left to right. So 4 is less than 5. It is possible to read it the other way around. You could say 5 is greater than 4 and read it that way. So if you're going to think of the sign, as the less than sign and read it as less than, you've got to read it from left to right. And so let's jump in and do example 1. So for example 1, we're going to describe the values of x that make the inequality true in words. So we're first going to do it in words, and then we're going to list a few numbers that do make the inequality true. So for this first inequality, x is less than 5. We're looking for values that are smaller than 5, not including 5. Okay, so we don't want to include 5. So some values that might work there might be numbers like, negative 100 is less than 5, negative 1 is less than 5, 0 is less than 5, 1.2 is less than 5, 4 is less than 5. So there are infinitely many examples that would work there. Those are just a couple. Okay, for B, we've got x is greater than or equal to 5. So we're looking for values bigger or larger than 5 or 5 itself. So 5 also counts because we've got the greater than or equal to sign, so it can also be 5. So we could list numbers like 5 would satisfy this because 5 is greater than or equal to 5. It's equal to 5, so that works. So 5 works. Or 7 is greater than or equal to 5. 1,000 is greater than or equal to 5. You could have a decimal. 8.3 is greater than 5. There are infinitely many answers here also. So for C, this is a different type of inequality because you've got the x in the middle, and so this is what we call a compound inequality. So we read this, x is greater than 2 since the bigger part of the sign is closer to the x. So x is greater than 2 and it's less than 7. So really what this means is it's between 2 and 7, and we're not including 2 and 7 because we don't have the line underneath the sign. So don't include, or we could say, but not 2 or 7. So any numbers that are just between, so numbers like 3 or 4 or 5 or 3.6 or 6, all of those numbers are between 2 and 7. And then for the last one, we've got another compound inequality. This says x is greater than or equal to 2. So even though this symbol right here is a less than or equal to sign, because we're reading it from the direction of the x, we're saying x is greater than or equal to 2 and x is less than 9. And so we're looking for numbers here. So values between 2 and 9, including 2, but not including 9, because we have the line underneath the symbol next to the 2, but we don't have it with that 9, so it's just less than 9. So we could pick numbers like 2 would work, since x is greater than or equal to 2, it's equal to 2. 3.1 would be between 2 and 9. 4 would. 8 would. We could think of even like 8.9999, something really, really close to 9, but just not including 9 would count. Okay, so let's do our last example here. So out of just these numbers, 1 through 10, which ones make the inequality true? So we're looking for an A, we're looking for x is less than 5. So all values that are less than 5, and remember, are not including 5. So that would be numbers like 1, 2, 3, and 4. For part B, x is greater than or equal to 5. So here we've got numbers that are greater than 5 and then also including 5. So I'm going to start with 5 and then all the numbers in the list that are greater than 5. And then for C, x is between 2 and 7 or greater than 2, less than 7, not including 2 and 7. So I'm going to start with 3 because we don't want to include 2, and 3, 4, 5, 6, and I'm going to stop there since we also don't want to include 7. And then last for D, we want x numbers that are greater than or equal to 2 and less than 9. So I'm going to list 2 since it can be equal to 2, 3, 4, 5, 6, 7, 8, and then I'm not going to include 9 because it doesn't include 9.